In the previous video, we learned some of the basic functions like you can say the length, space, zeros, determinant. So these basically are the, you can say, the built-in functions that MATLAB library has, right? So let's say that we, like the last time, I will just copy it. If we have this A matrix, we have this A matrix here. So this is the A matrix. So if we see that our function size is a function that is found in the basic library of the MATLAB, right? So the function size takes any value in the matrix or vector and return two values, right? The first one and the second one, the rows and the columns. But there are some functions. This is the function that takes in one value and returns two values, right? So, but we see like the length function. Let's just use it. Let's define a vector first. Let's say we have this vector, right? So the length function, when applied here, so length function takes in one value and return one value, right? So there could be functions which can return one value, and there could be functions which can which can output more than one value, right? So there is some very useful thing that we can do with MATLAB is that we can write our own functions, right? So we have studied the bisection method. So we will implement this using the MATLAB function. So let's see that what are the inputs that we require and what are the outputs that we want. So in order to define a MATLAB function, first we need to do is use the basic terminology of the function to define it. Function, let me write C is equal to bisection. So whenever we will define a function, we will set function. So the MATLAB will know whenever we write function that we are going to define a function. All right. So function, I said C is equal to bisection and this terminology. What it means is the term on the left side of the equal says that it is gonna return only one variable. All right. So it will return only one value, that is C, based on what we want here. So we have defined that basically uh, the value of the C, right? The value of the C is basically our required value. So we want to calculate the value of C. So we only need value of C from our function that I have defined as bisection. All right. So I have defined a function and we named it as bisection. So what it is input? So we have to give it a function. So what was a function here? So this is our function, right? X cos x plus 1. All right, so let me highlight this one again. So this one is our function, right? So x cos x, this we will give this function, and we need to give it these parameters, these intervals. All right. So it's not gonna calculate the interval based on itself. So we need to give it a and b values also. And I have defined this the new value here, k max. So you know that we have find like two. So we have taken the two iterations here. All right. So we have just calculated the two iterations. All right. So we are using this k max term so that we can notify our function that we want that much iterations. For example, you can say like we want 10 iterations or 20 iterations. So we want our function to give us that number of iterations so that we may control it. And similarly, in the here we said that we can use some kind of parameter to stop it. So maybe that could be this. So we are using the toll or the tolerance here so that we can use the value from here to manipulate or to decide when to stop. Right? So our function here, the bisection function here, we're gonna need function, the two values a and b of the interval, and number of iterations we want to do, and the tolerance or the precision or the accuracy we want. Okay, so these are the function parameters. So let's look at what the first thing we should look at. So the first thing we should be very much, you can say, put our eyes on is that this condition. Right? So this was our main condition, that f of a and f of b should be less than 0. There may be possibility that whoever uses this function can put a and b value that may not include the root values, right? So f of a into f of b could be greater than 0. So if that is the case, then our function should return that they have entered the wrong value. So for this, we will define an if function. So I will talk about the if function. F of a, I will just write it and then tell you about it. So f of a, if, let me just put it in the Matlab. If f of a steric, I will multiply by f of b is greater than 0, then c value is equal to all right. So we use if and else statements to represent some conditions. All right. So whenever we use if, and you can say if or for or else or while, we have to give the end statement. All right. So for example, if I start another if statement and then write some conditions like we have different conditions. For example, we can say a is equal to b. We have to use double equal marks to say if a is equal to b. Similarly, if we want to say if a is greater than b, then we use this notation. Alright. So if we have to say like if a is less than b, so we have to use this terminology. Right. So we want to say like a is greater than equal to b, so we're going to use this one, right? So these are the different you can say the conditional parameters we can use in if and else statements. All right, so whenever we give one of the such conditions, it will verify the first line that we write after if statement and then move downwards. So we can see that indentation, that space in there. So if this condition is true, false, or whatever we have done it, if it is whatever condition we have given, if it is true, then it will come to the next line, just like here. So we are saying like if f of a function value at a and function value at b have the same sign, then our bisection function cannot calculate the root value. So you just put failure. All right. So in MATLAB, if you have to give the string value, if you have to give the you can say the written text value, then you have to give it with these one single commas. All right. So we'll just give them the return. So for it will say C is equal to failure and then return. Return means that it will pass on the value of C to the outside, right? So it will come out of this if statement and will not execute the later code. So if we don't have the return here, so it will keep on going downwards and execute the plan. If we hit return here, so it means that just go outside and just finish the task. Just come out of the loop. Right? So this is the loop from 3 to 6. All right, so this is the if statement. So whenever we use the if statement, we give some condition, like we can say that a multiply by b. So we were saying that if a is equal to b, then a multiply by b. We can also use the else statement, like if a is not equal to b, then maybe a divided by b. All right, then we must have to use the end statement to close this. All right, so you can just see that whenever I type end, it just highlight the above if to make sure that this is this everything is closed now. Alright, so we have used this AND statement here to close our if loop. You can also keep in mind that whenever you find anything difficult or not understandable, you can just type doc, and let's say if you want to look at the documentation of if else statements, then you can just type doc if, and it will open you to that if else if statement. All right, so all of these things is explained here, and with many examples. So use this to remove if any further questions you have. All right, so now that we have made sure that uh, that the interval values given by the user of this function are correct, the interval values are correct, that means that this condition we have made sure that if a and b are giving the positive values after multiplication, that means that our function will just give that 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 the root is failure. All right, so after making sure of that, what we need to do is let's define another for loop for k. So what we have done here is we have defined another variable k, whose value we have defined a for loop. All right, so uh, it is reminding us that we have to use the AND statement to close it also. So as we have talked earlier also, that if we use any of the if else statements or the for or while loop, we have to use the AND statement to finish them. That will start from the value of the 1 and can go up to the value k max, which we have taken as an input, and defined another variable c, as this is the value we want to find, c1, that which is equal to a plus b by 2. So c, we have defined c which will be equal to a plus b by 2. Both a, b and k max also is, you can say, is being input to this function which we are defining as bisection. So what it really means, we will also, you can say, when we will complete this code, it will be more clear that why we are doing this. So now I define another, you can say, an if statement, and I define that if the value of the function is equal to c equal to 0, then return. Otherwise, if Alright, so what we have done here is, this is the main for loop. This one that is minimizing, and that I'm minimizing here is the main for loop. So for this for loop, one thing you must be clear that the whatever code we write will be executed from these lines 1, 2, 3, 4, 5, and this will go downwards. So when the computer will run the code, it will first execute the line 1, then line 2, line 3, line 4, and so on. So it will execute up to the line 6, which we have already discussed. Then it will come to the line 8, which is the for loop. So for the for loop, the k value, the initial k value will be 1, and it will increase to the k max, but initially its value will be 1. So after getting into this loop, its value become 1. Then c we have defined will be equal to a plus b by 2. So it will find the first c1 value when k will be equals to 1. So it will find the value of the c which is equal to a plus b by 2. And then it will check if the function value at that c value is equal to 0 or not. If it is equal to 0, it means that we have already that our c value is already relying on the root value. So this means that if function value at the c is equal to 0, then we have already find the root. Then the return means that it will get out of this loop. The return means that it will not execute the further lines of the code. The code will end. It will come out of this loop. Alright. If its value is not equal to 0, which will be most likely be the case, because we cannot mostly reach, you can say, exactly uh, at the root only at the first iteration. So after checking that if it will be equal to 0, it will get out of this loop. Otherwise, it will check if b minus a would be less than tolerance. For example, that we have set the tolerance of maybe 10 raised to power minus 2, or you can say that it will check if the tolerance limit, if the you can say the tolerance limit, or the value which we have given it, so that the a and b value, if it is already very small, then it's almost likely that we have already reached the root. So it will check the next thing, that if our desired tolerance limit is achieved, then it will get out of this loop. So first it will check if the value is equal to 0. If it's not the case, then it will move on. Then it will imply this if statement, and it will check that b minus a is fairly large than the tolerance value we have set. And if this is the case, if this is not the case, I mean, if b minus a is greater than tolerance, then it will further go down and come to the line 19. And it says that if f of b multiplied by f of c is greater than 0, which means that if f of b and f of c are greater than 0, then we have to change the value of b is equal to c according to our you can say the method we defined earlier. So otherwise, if it will be less than 0, then we want a is equal to c. So this is a very, you can say, a basic code that we have written for the bisection method. After it has been executed from the line 8 to the line, you can say, 22, it will move up again to the line 8. So this is why we define the loops, the for loop or the while loop. Because it is, if these conditions are not filled, it cannot come out of the loop and cannot execute the return command. So it means that it will still remain in that loop. It will remain in that loop until the k value has reached its limit of k max. For example, if we have set the maximum iterations for 4, at the first instant its k value was 1, it will keep on going the loop. Then after executing till the line 22, it come again to the line 8, and now the k value will become 2. It will increase, you can say, with the increment of 1. After, when the k value is 2, it will again calculate, or it will again go through all the line of code, and then after going through the line 22, its value becomes 3, and then again its value become 4. When its value become 4, our condition, you can say, the k value has already reached the k max value, and it will come out of this loop, and our the process will be finished. And you must see that here the c value is basically our root value, and at every iteration the value of c is being calculated again and again and again, unless our, you can say, the desired condition that f of c is equal to 0 or our tolerance limit has been reached. So now we will see how to use this code to, you can say, get the value. So let's define a function. What was our function? This was our function, and we want to use this code. One thing you must do is save this, you can say, document to some place where it could be found, and save. I have saved it to the bisection.m, and this you can say name should be remembered. So I've already saved it, so I will just cancel it out. So to define this function, I will use the MATLAB notation for this, which is that you can define any function f is equal to. So in this way we can define the function. What we are doing here is defining in the MATLAB, we can define the function in this way. We have defined it like f is equal to, it is in, you can say, in the variable of the x, and its value is x cos x plus 1. So we have defined x multiplied by x cos x plus 1. Alright, so let me if I run this code, it will ask me to save it first. So I will save it as we can say bisection practice maybe. Alright, so this one is saved. So when I have run this command, so you can see that one variable in our workspace as a function f is there. So now we need to use or find the root of our this function, this function, this equation that we with our you can say code. So we define, maybe you can write root is equal to bisection. So this name must be equal to that value that we have saved. All right, so you can see that I have saved my this function, this value is the same, this name is also the same, so we must call it with the same letter. If the upper and lower case letters are even changed, then it will not execute. So we need to call our function bisection that will give us the value of the root. So you must see that our bisection function takes 1, 2, 3, 4 and 5 values. We take 5 values as an input. The first one value is the function, so which we have already defined, so we will pass on the value of the f, which is the function. Next we need to give it to it is the lower and upper limits, a and b value. So what we can do is we can also find the value between -2 and 4. Let's define, we give the a value as -2 and the b value as +4. Alright, so this we have defined. So what's the next thing is the maximum iterations. Or so we can define any iterations, and let's say how many we have done here. Maybe we have gone from, you can say, the 10 iterations, so we can define k max as 10. And what's the next thing is the tolerance. Alright, so maybe define tolerance as e raised to power minus, you can say -2. Alright, so it means that 10 raised to power -2, we are using 0.01 is our tolerance. So let's run this function. It gives us the value as 2.0723, which is equivalent to 2.0723, which we find using the simple, you can say, hand calculation. So in order to see how it is calculating this, I will further let you set, let me see, clc and clear command, and I will add one thing here is the breakpoint. Alright, so now you see when I run this function, it comes to that point. Now you can see that these things are defined: a, b, function value, 10 iterations, and the tolerance value. Tolerance value is 0.01. Alright, so this is the tolerance we have given. So now you can see how the computer is operating by inducing every step. So computer is executing, our MATLAB is executing the line 3 code. So what it is doing is checking the function value at a multiplied by function value at b, if it is greater than or equal to, if it is greater than, its value is not greater than 0, so it doesn't come to this, you can say, this loop, and move on and skipped these lines, because this condition, this if condition, was not satisfied, because we know that at -2 and 4, its value is it follows this condition, f of a and f of b is negative, so it doesn't execute this code. Alright, so it means that our limits a and b are correct. So now it comes to the line 8. Now what it should do, it should define the k value as 1. So what we see here is, I will press the next step button, so you can see that now the k value is 1 is defined. Alright, so now what it should do, it should calculate the c value, which is equal to a plus b by 2 and divided by 2. So in the next step, you can see it has calculated the c value, which is equal to 1. So you have seen here also in our example that the first c value which we had calculated was equal to 1. Alright, so this you can see here, this value is basically 1. So you can see here also c1 value is 1. So now it is checking if f of c is equal to 0 or not, which we know it is not equal to 0, because f of c1 we have calculated, which was equal to 1.503, which is not equal to 0. Alright, so next it will check if f of c is equal to 0, which it is not, so it skipped this line of code because this condition was not satisfied. Now it had come to the line 15. Now it has to check if our limit b minus a. So what is b minus a here? B minus a is almost, you can say, its value is 6. Alright, so it is not less than the tolerance, which is 0.01. Right, so it will also skip this line of code, because our you can say the tolerance is not greater than, you can say tolerance is not greater than the b minus a. So you can see it skips this line of code and come to here. Now it check f of b multiplied by f of c. So f of b was, what was f of b? F of b we know it was negative. Alright, f of b was negative, and f of c1 was positive. Alright, so if we multiply f of b and f of c, its value will be negative, and positive, its value will be negative. So this value could not be executed, so it skips this line of code because this condition is not filled, and because if it is not positive, it means this value is negative. So it replaces a with c. Alright, it has to replace a with c in this line of code. You can see here a value is 2 and c value is 1. After as we go to the next step, our a value has been changed to the c value, which is 1. Alright, so now it has to move again from line 22 to line 8. Alright, so you can see this again, the k value has now become 2, and it will again go through this loop. Now it will calculate the c value of c2 value. So you can see the c2 value is 2.5 as we have calculated. So we have calculated c2 value is 2.5. You can see c2 value is 2.5 is calculated. So f of c2 is still, you can say, not equal to 0. So it will also skip this line of code, and this line of code which also will be, you can say, skipped because the tolerance limit is still not achieved. So I will go to the next step, and still the tolerance limit is not reached, so it will go to the next step, and now it will also come to this line, and now we can see that f of b was, you can say, negative. This condition is true. Both f of b and f of c are positive. So now b will be equal to c value. So b will be 2.5. So you can see the b value has been changed to 2.5. So it will keep on going this loop until and unless our f of c becomes equal to 0, or b minus a is so small that it is, you can say, less than the tolerance value. B minus a is less than 0.01, which we have set. All right, so it will keep changing the c value. As you can see, the c value was 1, now it is 2.5, and next iteration its value will be changed again. So it will keep on changing this value, and you can just store in the system. At the end of the you can say all the loops, the c value which will remain will be sent to the you can say as an answer. As so if I continue and not move in the steps, so you can see the c value, which we call the root, is 2.0723. So the main things to notice here is that the function value returns, our function here, the bisection function, is returning only the c value, all right, which is the left side, on the left side of the equation, all right, and we have to call it with the same name as we did here. We define any function, and if we are calling the bisection function, it should be called with the same name, and all the parameters we define should be given to it. All right? So if I don't give any of this, you can say these 5 terms. If we don't give these 5 terms to this function, it cannot calculate the value of the c. It will give us the error. All right. So these inputs and outputs should be remembered, and you must also, you can say, practice or use the help and docs command to see if you don't understand any of this code, and modify it or use it in some other way. So there could be many different ways you can write the same code or get the same values from the MATLAB, or get the same algorithm, or get the same bisection function